Greetings, everyone, and thank you for participating in today's Trident Academy session, Smart Building, Trends, Standards, and Design. It will be presented by Mohamed Abdel Rahman, Senior Technical System Engineer at Trident Technology Services. I am Mai Nimr, Channel Sales Executive, and I'll be moderating the webinar for today. The webinar will start shortly. Please, if you have any questions, please submit them through the Q&A functionality in the control panel. Mohamed will be answering all your questions live at the end of the session. Thank you. Now, without any further delay, I leave the stage to Mohamed. Thank you, Mohamed.
Okay, thanks, Mai, for your introduction. Hello, everyone, and welcome to new sessions from Trident. Today, we will focus on the digital building, trends, market driver, standard, taking some considerations and some best practices related to the digital building infrastructure. So during presentation or during today's presentation, we will cover the following topics. First, in brief, we will discuss some basic information in very high level for the definitions of digital building, some trends related to the digital building and the digital building standard, related standard, that defines the digital building. Briefly, we will discuss how COVID-19 will accelerate the digital building and the new expectation derived from the COVID-19. Also, the digital building driver applications. One of the very hot topic, the future smart choice for the single pair Ethernet. So we will talk about the single pair Ethernet, how it's work. This is one of the future smart choice when you are going to have a larger distance for the IoTs, for the sensors. So we will talk in details about the meaning of single pair of Ethernet. And finish up, we will take some best practice, some recommendations when you are going to talk about intelligent building. So let's start with the digital building definition, some very high level informations about the digital building and its definition. Digital building is the meaning of digital building. It is a convergence of BOE, analytic, IoTs, network systems that brings them all together. So we need to bring all BOE, analytic, IoTs, the network, all systems inside the building to be convergence. So the digital building will be including the PMS, power over Ethernet for the LED lighting, as we said, the physical security devices, the audiovisual, EV, sensors, softwares, and analytic, to bring them all together. So you can be supported all this system by IP network, IP based. So you have a power management and control at the same infrastructure as a unified solutions. So there are many reasons to talk about the smart building or digital building, but one of the primary requirements for the digital building, it is the better management. To improve your visibility for your building, to have high efficiency of operations inside the digital building. So we need to have digital building solutions. So it can be create the workplace for the building. It make it more efficient, more cost effective, more employee friendly, as we will see in the upcoming slide. So now let's talk about the standard. There are several standards, several different key organizations when you talk about the standard that define the digital building, starting with TIA, BICSI, or Intelligent Building Institute. Most of all, it's defined the digital building in some way, like TIA, it defines digital building as digital building. It will be digital, it will be smart only when the building or systems are fully integrated together, to sharing the data, to be managed through the single pane of glass. So you have the building, it's considered smart based on the expectations and based on the integration between the different systems inside the building. Also, BICSI defines the digital building as a premises or utilized communication technology to integrate the building system, to allowing for the inter-system connections and to consolidate and provide environment which is safer, more comfortable, productive, and more efficient. So now the digital building related standard, when you are need to focus more about the digital building, one of the most comprehensive solutions or top or standard related to the digital building. As we said, there are many different standards talking about the digital building. The first one is SPE. Recently, it released, published a new update, new standard. It's called SPE 007. 2020, last year, it's published this standard. It is related to the ICT and information-based practices and for the intelligent building and the premises. Also the TIA 862-P, and now it is in the process for updating by -C. It will be published this year, expected this year or next year. But now we have -P, which is related to the standard for the structure cabling infrastructure when you are talking about the intelligent building. Also, the ISO part 6 from the 11801 and also Synelic have a standard related to the digital building when you talk about the digital building standard. So now, as you can see here, historically that we have the LAN inside the building. In the past, you have already work area. It can be support for your desktop or for your IP phones, for the data, for the voice, and then it added by the wireless access point inside the building. But now, as you can see here, the digital building, it have many different systems like BOE LED lighting, HVAC. You are talking about the sensors. You talk about the building automation, HVAC, video surveillance, wireless. So we need to have a trend now to make it more digital, more intelligent, more convergence, as we said. In the left here, you can see different layers for the digital building, starting with the edge. This is the edge for the digital building, like sensors, smart devices that make some intelligent analytic inside the digital building. It is only completely supported by IP. The digital building needed to be supported all systems by IP network and run all over a structure cabling system. You need to run the systems, all the system inside the building to be running using the structure cabling system and managed, controlled by IP switches to make some management. And finally, the application, you can see here, this application, application can be run for the network and remote devices can be used, the remote devices to making some management for the lighting, for example, for the lighting system control. So you can have a remote management for your system. As you can see here in the past, as we said, in any building, there are 3 elements or 3 systems available inside the building, starting from the building automation system, talk about the security, talk about the communications like data and voice. So there is in the past, the 3 different elements or systems available in the building. All of this part of this building required today to be convergence move, to be convergent. And we said we need to have IP based, we need to running PoE for the system. All this system created data. We need to be have some analytics, analytic software for this system. You need to have more information about the building. So the data has to be going now. As you can see today, the building will be convergent. As we said, you need to send the data, all this data, to send it to the data center, edge data center, or even cloud data center, organizations or premises, third-party data center. But we need for the building to send all this data to the data center to making some analytic and making some more efficient, as we said. As shown here, as we said, we have the security, the building automation, the communications. This is the 3 different systems available in the building. The separate security and lighting and wireless, it is available, each one. You have here surveillance and the security. You have the lighting, it's available in BMS. And also for the wireless access point available, or wireless solutions available in the communication. So now you need to have more interconnections, we need to have more conversions, like you need to be connected to the security. We need to have, for example, Wi-Fi now. the Wi-Fi for the lighting. It's connected to the wireless network. You need to have more sensors. It's connected to the HVAC. So we need to have a centralized, as we said, sorry, we need to have a centralized monitoring. We have to connect all systems together to making some central monitoring and management. You can see here, this is the example for the digital building, or everything is talking to everything nowadays, and using the digital building, all the network connected everything to everything else. So you can see here, this purple one, it is like for the data inside the network, and the data, it's transmitting data or power inside the network. So all, as we said, all the network, all data, everything, it will be connected to everything inside the building. So what? So now, in briefly, 1 minute talk about the market, how the market is look like when you talk about the digital building. It is now in 2017. The digital building market, it was around $10 billion, but in 2022 it's expected to have projection market size to be 17 billion, with forecasted around 11.6, as you can see, 11.6 annual growth. Also, the largest segment for the digital building, it is for the commercial, the fastest growing. We talk about the healthcare, the most referent educations, the new constructions. This is all some summary for the market for the digital building. So now let's talk in brief about the accelerations for the digital building before going to the best practice and single pair of Ethernet, as we said. So have a brief about the accelerations of the digital building. This is the acceleration for the digital building. As we said, and as you mentioned here, in last 12 months, in last year, we have seen a lot of more interest or willing for invest for the smart building capability. With the change due to COVID-19, all business are reviewing the role or the expectations when you talk about the office building. So the people and the employee now, most of the employee are worried about the environment, need to have more safety. They are worried about going to the office. But as we said, the employee are agreed that the office is very important for the collaborations, for the relationship building between the employee. So most of them, as we said, the employee said that the health is very important for them and for the family. So to meet all this changing demand, we need to have accelerating to investment for the technology to ensure that we meet the requirement in the future. So we need to invest for the building infrastructure, as we will see in the following slide. Also, after COVID-19, it's very important to answer questions that how and where the work it will be happen. As we said, working from home or working from the office, the remote work is proving to be successful, but we need to now to have more collaborations, more having more meeting with the client physically. So it is very important now to bring value to the employee and provide a reason to leave their home and coming back to the office. So the infrastructure for the office too, this is the meaning of the office too. The office need to be the place where and the people want to work and want to return back to the office. The outcome from the digital building. To answer these questions, one of the biggest benefits when you are talking about the digital building, it is the energy management and the efficiency. So this is the one of the best or one of the biggest benefit to have some energy management for all your systems and to have more efficient building available. So also the reducing for the cost, operating cost, understanding how and when and where the data is consumed. It's very important to know the how and where the power consumed or energy it will be consumed. One of the also the very important outcome from the digital building to improve your business and to drive for more for the predictive maintenance. Predictive maintenance, it is a program based on the analytic or based on the analysis for the data collected to making the predictive maintenance. It will have around 10 times return of investment instead of using the preventive maintenance. Preventive maintenance, most of the building using the preventive maintenance, it means that you have a scheduled maintenance, but using the digital building, it will have more focus or drive for the predictive maintenance. Also, one of the hidden benefit when you are talking about the digital building, the hidden benefit or intangible benefit, increase the employee productivity. This is also some building or digital building adoption. When you are, as you can see in the graph, you have different customer will be adapt for the intelligent building sooner than others. So as you can see, many customer will have adapt or need for the digital building more than other. For example, luxury hotel. Luxury hotel is always looking to provide the guest with the most experienced, most intelligent building. Also for the high educational, we are talking about the high educational, it will be also institute wanted to attract and best to give most talent to the institute or to the student. So it's very important. They have the high budget to making the upgrading in the future. The lowest one, it will be the retail. The retail is just starting for the building automations to encourage people and increase the shopper coming to their retail instead of using the online shopping. So the transition to the digital building, as you can see here, this is all systems available inside the digital building. We are not there yet. We don't have all systems are convergence nowadays, but the AV and audio, the AV, voice, data, all most of them, it's nearly 1% Ethernet nowadays. When you talk about the security and the lighting, it is headed to the directions to making Ethernet solutions. The rest of the building, as you can see here, the blue boxes, the rest of the digital building are lagging in terms of installed base for the digital building. So now let's have also some very brief about the digital building drive or the application when you are talking about the digital building. As shown here, there are many different cords available in the building, talking about HDMI signals running for the HDMI cord, the optical audio, the power cord, USB. So now we are seeing to make some simplifications for the cord and the power to transmitting the power, the data, the different signals. We need, as you can see here, we need to have a universal socket that to running most of these signals. So the RJ45, it is the global unifying connectors. It will be connected all systems. It's a global unifying connector, and every data socket in the world, it will be RJ45 in the future, and sooner it will be single pair of Ethernet, as we will see in the following slide. The meaning of single pair of Ethernet and the connector used for the Ethernet, like this, for example, it's called modified LC connector. So this is the transitions for the different cables on different port. It will be available. Also, let's have some history when you are talking about the structured cabling system. The structured cabling system, as you can see, it started before 1995. It started in around 92 or 94 by Cat5e to running the IT for the data for the desktop only. Then in 1995, as you can see here, it's starting to have to see Cat5e running with 10 megabit per second, to starting to support the voice and data. Around into 2005, it is starting using the Wi-Fi. The Wi-Fi starting to be convergence with the structured cabling system. And in 2010, the BMS or control is starting to put more applications, single dashboard by using the Cat6 cable. Most recently, as you can see here, the sensing by 2019, the sensing you need to have more sensors inside the room, sensor to making turn on or off for the light, for example. You need to have the PoE starting in the building to support using the structure cabling system. Also the AV to be supported by IP also, or Ethernet is being added to the network. So it now also available using the IP based. So all of them are going to the structure cabling system, and the increasing, it will not stopped. The next phase for the future, the single pair. The single pair, it will be the future, as we will discuss in the following upcoming slide. And as you can see here, starting from 1995 up to now 2020 or 2021, every time the structure building system is not for today, you are installed the structure cabling, you will not upgraded it. It can be supported up to 25 or 10 or 15 years to be upgraded. It is not like the software or hardware that can be upgraded from 3 to 5 years. So it's very important to invest for the structure cabling system to support most of these systems that will be running using the structure cabling in the future. Okay. Also, when you are talking about the PoE, we discussed in last sessions in last webinar, talked about the PoE and the importance. When you are talking about the PoE, we can be grouped the application into 3 areas. The first area, it is for the high power and high bandwidth systems. The second category for the low bandwidth, high power. And the third one, it's for the low bandwidth and low power. So you have 3 different categories inside the building to support it using the structure cabling system. The first one, high power and high bandwidth. The recommendations and most of the standard recommendation to going using Cat6a cable to can be support the 10 gigabit per second, and can be support the PoE or PoE++, as we said before. PoE++ can be support up to 171 watt in the building. Also the low bandwidth, high power, it's also very important. About when you are going to talk about the lighting, talk about the security cam, need high power but need low bandwidth. You can be using Cat5e or Cat6, but you need to consider the bundling of the cable when you are going to talk about the PoE++. As we said before, the most recommendations also to going using Cat6a cables. The final one, it is a low data, low bandwidth, low power for the devices like fire sensors, like the valve controller. You are talking about the biometric access control. You can be using Cat5e or Cat6, or the new SPE. SPE, it's called single pair of Ethernet. You can be using 1 pair. It will be available very soon to support single pair of Ethernet, and can be transmit the power inside the single pair of Ethernet, and it's called PODL, power over data line. And we will discuss also and mention how many power can be supported when you are going to using single pair cable. Okay, now one of the hot topic, as we said, it is running now and is in development starting 3 years ago. It is a single pair of Ethernet. Single pair of Ethernet and how it does it work. Okay. As we all know that Ethernet, it started by Ethernet and fast Ethernet up to 100 megabit per second, and to support 1 megabit per second, it's called fast Ethernet. And only we used only 2 pairs, 1 pair for the transmitting and 1 pair for the receiving, unidirectional. Then the started for the gigabit Ethernet or 10 gigabit Ethernet transmission, the extension or extended from the 2 pair to 4 pair. Every pair will be transmit and receiving, starting from the Cat5e to support 1 gigabit per second. You having transmitting and receiving bidirectional. It means that every pair it will be transmit and receive to achieve the high power data rate. Then now the new published single pair of Ethernet from the IEEE, it's published, it started, you will be surprised that it started in 2015 and have many updated. So the single pair of Ethernet standard, basically it is only one pair. It is a bidirectional. You can be transmit and receive on the same pair. It will be used for the home automations, the industrial applications, and it also used for the automotive technology. So you have three different applications when you are talking about the single pair Ethernet: for the industrial, for the automotive, for the building automations. We will talk about it in the following or the upcoming slides. The single pair Ethernet, it allows for the Ethernet transmission using the two pair. Also, okay. So the target now, as we said, you need to transmit and receive only in one pair and achieve a higher distance instead of the limitations of Cat5e or fast Ethernet or gigabit Ethernet or 1 gig base -T. It is limited to 100 meters. So let's talk about the single pair of Ethernet standard. As shown, this is the IEEE.3 standards. It is coming from the working group. It defined and developed many standards for the single pair of Ethernet. It started in 2015. As you can see, it's called 100 base -T1, or called .3 PW. It is used for or targeted for the automotive or transportation application. It can be supported for 15 or 40 meters. 40 meters, so you need to have shielded solutions, or 15 unshielded solutions. Then followed in 2016, it started 1000 base -T1. It is called .3 BB. It is also a shielded solutions, can be supported up to 40 meters for the shielded and 15 meters for unshielded. Then another very important standard, it's called .3 CG, which is published in 2019, and it's approved by IEEE. Standard for the low transmission speed. It can be support 10 megabit per second, but this topology can be support using two different topology. It is defined by IEEE. As you can see here, it is defined by IEEE T1L for the long range or long reach. T1S, it's for the short range reach. So we have 1000 meter, 1 kilometer to support 10 megabit per second using the shielded solutions, or you can be using for the short range for the 25, and we will discuss the meaning of 25 and multi-drop can be used especially for the building automation application. Then finally, last year, IEEE defined a new standard. It's called multi-gig. Multi-gig, you can be support higher data rate, but up to 15 meters when you are talking about the Ethernet or the single pair Ethernet, and it's only defined by IEEE using the screened or the shielded solution. So now we have 4 published, 4 approved standard. One of the main or important one, it's called .3 CG. It's published in 2019 and can be supported up to 1 kilometer. 1 kilometer, you can be between the switch and the device. The meaning of power over Ethernet, it needs 2 pairs to transmit. This is standard for the, it's called power over Ethernet. It requires minimum 2 pairs to transmit and receive. You have here the positive and negative, and also it is using like a center tab here or inductive to transmitting the power. And also for the PoE++, as we said before, PoE++, you are using 4 pairs. But the single pair of Ethernet, you have only 1 pair. So the power over Ethernet circuit doesn't work with it. So IEEE defined a new standard. It's called .3 PU. This is a new standard, and it's called in trademark or for the market, it's called BODL. BODL, it means power over data line. Power over data line, it is the concept for the transmitting power over the single pair of Ethernet. As you can see here, it is very simple circuit developed for the single pair. As we said, we have only single pair. So you have here high pass filter and low pass filter. It is used as a capacitive solutions to transmitting and receiving the power. The IEEE defined 15 classes starting from 7 watt up to 50 watt. So you can be transmitting up to 50 watt. But as we said, the single pair of Ethernet can be support up to 1 kilometer. When you have 1 kilometer, you can have up to 7 watt because the power is decreasing using the distance. So very quickly, the single pair of Ethernet. Where can I use the single pair of Ethernet? The Ethernet at the edge of the building automations. As you can see here, any building automation, it have 3 main layers: the field layer, automation layer, and management layer. Using the single pair of Ethernet, it will be secure, reliable, and cost-effective way to bring Ethernet instead of using different protocols, different language between the devices, between the different systems. So single pair of Ethernet, all systems will be IP-based Ethernet. So as we said before, everything will be talking to everything. So instead of using the traditional field bus, you can be using the more reliable and more cost-effective single pair of Ethernet. And it can be directly connected, these field sensors, directly to the switch. And the switch, it will be using in the automations level and be connected to the management. Also, one of the applications for the single pair of Ethernet for the industrial automations. Industrial automations, it's like the building automations. You have the field layer, you have the automations layer, and finally for the management layer. Also, single pair of Ethernet can be used to connect all these sensors together to the Ethernet switch. And it will be reliable and cost-effective to bring the Ethernet, as we said, to the field devices inside the industrial system. To transmit or to connect from the switch to the field device or device for the building automations or industrial automation, as we said. IEEE.3CG, as we said, it is published in 2019. Standardized 2 different topology or 2 different physical layer topology can be connected. The first one, it's called T1S. T1S, as we said, it is used for the short distance. Can be connect different devices with multi-drop up to 25 meters. So you can have the distance from the network switch up to the final one, 25 meters, and you can making multi-drop from the sensors. Can be if you have more informations or have expert in the automations, the devices or field are connected in series or can be connected together and using only one cable. So this topology, it will be very important inside for the building automations. And it can be support up to 10 megabit per second. The second one, or second topology, famous topology, it's called T1L. T1L, it is enabled for the point-to-point. It can be support up to 1 kilometer. I think it will be very useful for the industrial applications, for the machine, for the manufacturing. You can be support up to 1 kilometer for the 10 megabit per second, low bandwidth required. And also it can be support up to 10 connections. As you can see here, 1 kilometer using the copper, single pair copper. So you can be supported or acceptable to having 10 connections. I think you all know that for the Cat6 or Cat6A for the Ethernet, the 1 gig Ethernet, you can have up to 4 connections between the switch and the device, but here can be support up to 10 kilometers. And also TIA, as we will see in the following slide, it defined also 2 different performance. It's called SP1 and SP2. SP1 for the 1 kilometer and SP2 for SP1-400 used for the building automations. This is a summary for the TIA standard. It's related to the single pair of Ethernet. I think most or all this standard, it is now in the development, and it is now published as a draft. It's not approved, but you can see here the TIA started after the IEEE to making some development, to making your documentations or standard for the SPE to focus on the cabling, the connector used, that can be support the 10 megabit per second applications. For example, you can see here 568.5D. It is -D. It is a revision for the balanced single pair of Ethernet for the cabling and the component standard. It is drafted now, as I said, and also it is related to the building. For the MICE 1 for the mechanical, ingress, chemical, and electromechanical with the entry level. So this standard will be focused on the building for the connector or the performance inside the building automations. Also 5071, it will be focused on the field test, how you can be test for the single pair of Ethernet, the test equipment and the requirement to test the single pair of Ethernet. And also -C, it's now in the developed, as we said in the first of the presentation, that -P, it is published, but -C, -P 862-B, it is related to the intelligent building. In the new revision, it will be added for the single pair of Ethernet and the requirement to have inside the building. In the TIA, the standard, it is for the single pair of Ethernet media. It is said that the cable gauge, it will be between 18 EWG and 23 gauge. It can be shielded or unshielded based on your applications, based on your environment that will be installed for the single pair of Ethernet. But the expected 2 area for the single pair of Ethernet cable, it can be used for the industrial, it can be used for the enterprise, as we said. For the industrial, to achieve 1 kilometer for the transmission of 10 megabit per second, you need to have 18 EWG. It's like the power cable to achieve the high distance. So we need to have 18 gauge for the diameters of the connector. This is the 18 gauge for the cable. It can be supported also, as we said, from the TIA, it is mentioned that you can be support up to 10 connections in the one channel. So you can be using it. For the industrial solutions, the recommendation to using shielded cable, it will be shielded to perform the E2 and E3 environment. As we said, for the industrial, you have electromagnetic interference. So to having to maintain or to avoid the interference from electromagnetic, you can be using the shielded solutions. For the industrial cable, you can be using 23 or normal 23 EWG. As you know, for the industrial, you cannot achieve more than 400 meters to connect those devices. As TIA also, it is defined it as SP1-400. It is a standard or category performance for the enterprise to support 400 meters using the 10 megabit per second for the cable. The second component for the single pair of Ethernet, it is a connector. Nowadays, you can see many different, around 7 or 8 connector can be support for the single pair of Ethernet, but all of them are in development. We have only 2 connectors or 3 connectors to be 3 connectors. Now it is approved from the TIA and from IEC, and it's published. The first one, it's called modified LC. Modified LC, it is approved in 2019 to using in the building for the IP20. And also another one approved, it's called IP67 for the M8 connector used for the industrial solutions. Also this one, it's approved last year, can be used for the industrial applications. It is called IEC-Type 6. This is the first one for review. It is called modified LC or modified LC connectors. This connector is approved now, and Band would have published this connector, and we have it manufacturing it now. The mating phase, it is a type 1. It is like the fiber LC, modified LC. It is around 70% smaller than the RG45. The name, it's coming from the form factor. It is the same like fiber LC connector, and also it includes a latch for engagement to ensure that the connector is remain in the placing after the installation or after connections to the device. It is IP20. IP20 can be used for the mice one or for the building, can be protect for the dust, but you don't have any liquid protections for this connector. One of the very important for this connector, it is a toolless field determination. So you can be connected it without any tool. The second one is SPE connector IP67, which is suitable for the industrial solutions, MICE 2 or MICE 3. And now it can be used for the harsh environment, for the manufacturing. Can be used this connector, M8 connector with a lock. This is also the example for the difference between the 4-pair and single pair of Ethernet. The 4-pair, I think most of you know all information about the 4-pair. You can be supported data rate up to 10 gigabit per second using Cat6a cable. It can be reached up to 100 meter. You can be support using the PoE++. You can be going to 71 watt at the powered device, and also for the high density for the one rack unit, you can be connect up to 48 port in one rack unit. But when you are going to the single pair of Ethernet, as we said, it can be support 10 megabit per second, one of the famous standard for 8.3 CG, can be support 10 megabit per second, can be reached up to 1,000 meter. And also one of the very important, it can be support for the power over data line, can be support for the power inside it, but it will be depend on the cable length between the switch and the device. And also it is IP20 for the connector. It's called the modified LC, as we said. One of the very important that you can be connect and support up to 96 port for one rack unit. So very high density for using the single pair of Ethernet. You can be imagine the difference between the both connectors, the RJ45 and the modified LC connector used for the single pair of Ethernet. And also this is the comparison between the different scenarios or different application, different let's say different protocols for the building automations and the industrial automations. As we said, T1L and T1S, the two famous standards, can be used for the single pair of Ethernet, and it can be support up to 1,000 meter or 25 multi-drop. Finally, 2 minutes or 3 minutes, I will go through the best practice or infrastructure can be supported for the intelligent building. We have only 3 minutes here. This is the summary for the best practice for the intelligent building. To have the convergence IP for the system, you need to have optimized the telecommunications room to accommodate as much as possible for the sensors, for the systems to be connected using the IP based. You need to design for the zone network topology to having more flexibility and reconfigurations ability. We need to plan for the convergence for the IP from day one for the automations in the future. You need to make the connections very easy and quick installations, move, add, change. And finally, we need to invest for the collaborations and room scheduling technology. So I have here one slide for each one to imagine and to know more about the recommendations. The first one, you need to have optimize the telecommunication room, can be accommodate as much as possible from the cabling. The recommendation that the telecommunication room isn't infinite, it is a finite space. So you need to using solutions like the 4-post or 2-post. You need to have 0 rack unit patching. You need to using the high density, the 28 gauge patch cord to can be support for the high density. It will be available in the future for the distal cabling. Also, one of the recommendations to using the zone application instead of the home run. Home run, it means very briefly to connect directly from the telecommunication room to the device. The recommendation now to making some zone application. Zone application, you need to have like zone areas to be connected using the red line, for example, here to connect to the zone box. Then you are distribute the cable to the work area. In bandwidth, we have a full range from the coverage or a reconfiguration product can be supported to have a zone cabling. As you can see here, also this is one of the new product for the consolidations point can be used, can be supported from 12 port up to 48 ports. And also you need to plan for the converged building. You need to think about the IP building automation systems, the future of the network, for the sensors, for the different systems. As we said, the security, the automations, the communication need all to have big convergence. So you need to plan for the IP. You need to have easy, quick installations and move at change. One of the recommendations to using the MBTL, we discussed it before, the modular plug terminated link, and also it is a direct connection. It is approved by the TIA in 2018, and you can be using it to connect for, especially for the digital ceiling devices. So for like access point, digital signage, or wireless cameras, or lighting, you can be using this system. Also, this is one of the easy or recommendations when you are talking about the move at change. The recommendation to using intelligent solutions. This is the solution from bandwidth. It's a new rapid identification labeling solution. It is a very low cost, let's say, infrastructure intelligent solutions. It is a barcode labeled on every batch cord available, can be get it from bandwidth for the copper or fiber, and you can be using the barcode scanner, this barcode scanner and the software, and you can be using them to making saved result. You can be validate your saving, you can be making some documentation, verify for the cabling without any disconnection or without any using special hardware to making some intelligent solution. So also we have a rapid ID solution. Doesn't need any special batch cord or any special hardware. Finally, you need to invest more in the collaborations and AV in the room scheduling technology. You need to, after the COVID-19 or the situations we have, you need to have, you need to answer the question. We need to reduce as much as possible the touch. You need to have a touch-free AV. You need to design fully automated meeting space without any touching anymore. One of recommendations also the AV design with to have no wires. You need to have automatic system, relay or triggers, automations. Bring your own device. It's very important to bring your own device, your trusted devices like computer, tablet, phone, and your own cable, and also to can be scanning the QR codes to make a control for the room, for the devices. You can be display automatically using the trigger after you connected your devices. Also the social distance, it will be very important after we back to the office. So we need to have a technology that allow for making presentation in different or multiple rooms. You are in, we don't have many people in the same room. You can be having many different rooms, and you can be present in multiple rooms. Finally, the installation need to be more easier, quicker programming. You don't need to have the expert to making your programming. All this, by the way, all these features, it's available in Atlona. You can be having the touchless, you can having low touch, social media supported, and the installation time is very simple. You don't have, you need to have tools or any dongles or any programming to making monitoring or remote monitoring for your system. Now, I think we have passed the time. Thank you for your time. And if you have any questions, feel free to ask in the chat box.
Thank you, Mohamed, for the very informative session. Before we can start the questions, I'd like to point out that at the end of the webinar, a survey will pop up on your screen to collect your feedback on today's session. So please, your input is highly appreciated, as we are always looking to optimize our work to fit your expectations. Now we will be back to Mohamed with the question. The first question, Mohamed, does the single pair Ethernet a complete system separate than the 4-pair system? I mean, does it have the patch panels, patch cords, and etc.?
I think yes, as we said before, the single pair of Ethernet, you need to have a different system, and the recommendation to making new cables, new infrastructure, and you need to plan it from the first. Especially when you have 1 kilometer, you cannot using the existing cables or existing infrastructure to support the 1 kilometer with 18 EWG requirements.
Another question, do I need new cables or can we use the existing one for SPE?
Yes, the same as we said, the recommendation to using a new cable, especially when you are going to the application, like the industrial application, that is need 1 kilometer to be supported between the switch and the device, so that the existing cable it cannot be used and can be not supported for this application. And also based on the TIA standard, the recommendation it have a scenarios to test your cables and making some to reuse, to making some point or some sets of testing to using your existing. That's the recommendation to having a new cables and new hardware.
How many numbers of drops acceptable for 10-base-TIS?
As you said, you can using only one cable to connect it from the switch, and you can be support up to 8 drop. It is acceptable with 25 meters between the switch and the final device. Okay.
What's the frequency range specified for 10 MPS SPE?
The frequency range, as we all know that for the Cat6, it is 250 megahertz, 250 megahertz. For the Cat6A, you are using 500 megabit per second. But for the single pair of Ethernet, the range of the frequency mentioned by the TIA from the 0.1 megahertz up to 20 megahertz to support 10 megabit per second.
Thank you, Mohamed. We don't have any more questions. Thank you, everyone. I hope you all enjoyed Mohamed's presentation for today, and it has expanded your knowledge on the latest smart building trends and standards and design. Please, if you have any questions on the presentation, contact Mohamed via his email address, or you can send us an email to support@ititrident.com. Once again, thank you all for attending today's sessions, and we're looking forward to see you in the upcoming Trident Academy session. Thank you, everyone. Thank you, Mohamed.